hydrogen are present in a 1:2 ratio by volume in water, and water, that is H2O, can be separated into its constituents, hydrogen and oxygen, by electrolysis, but cannot be separated into its constituents by any of the physical methods such as distillation, fractional distillation, etc. Also remember that the properties of a compound are different from those of its constituent elements. For example, the elements hydrogen and oxygen, being gaseous in nature, combine to form a compound, water, which is a liquid. Mixture can be classified further based on the uniformity of the particles present in it. If the particles are distributed uniformly throughout the solution, then it is a homogeneous mixture. For example, sugar solution is a homogeneous mixture because sugar particles get distributed uniformly throughout the solution. If the particles are not distributed uniformly throughout the solution, then it is a heterogeneous mixture. For example, sand dissolved in water is a heterogeneous mixture because sand particles are not uniformly distributed throughout the solution. A mixture can be separated into its constituents by physical methods. For example, a mixture consisting of iron filings and sulfur powder can be separated by using a magnet, that is, by magnetic separation. As we learnt, matter is anything that has mass and occupies space. Every substance is made of matter and has unique properties. We can classify properties as physical and chemical properties. Let's learn about them. We have with us a rubber ball. Let's see how we can describe it. By looking at and feeling the ball, we can see that the ball is a solid. It is round and yellow in color. It smells like rubber and it bounces. Now, let's observe this block of sulfur. We can say that sulfur is a yellow solid crystal and has a strong odor. What we saw are the physical properties of a rubber ball and sulfur. These properties can be easily seen or felt. Thus, we can say that physical properties are those properties that can be measured or observed without changing the identity or the composition of the substance. Color, length, mass, area, texture, elasticity, odor, melting point, and boiling point are examples of physical properties. Physical properties help us describe a substance. However, the description is not sufficient to identify a substance. For example, saying that sulfur is something that is yellow and solid and has a strong odor is not enough, because there can be many solids that may have the same properties, including our yellow rubber ball. Hence, it is necessary to also know the chemical properties of a substance to identify it correctly. The chemical properties of a substance can be observed when a substance undergoes a chemical change. Flammability, reactivity to an acid, and reactivity to water are examples of chemical properties. For example, if we burn sulfur, it produces a blue clear flame. Thus, The blue clear flame is a result of chemical property. When performing a chemical experiment, scientists study the properties of substances. This involves measuring the quantitative properties of a substance. A quantitative measurement comprises a numerical value and a unit. For example, this block of sulfur weighs 200 grams. Here, 200 is the number and grams is the unit. The units of measurement are derived from two systems, the English system and the metric system. The English system included units such as yard, foot, inches, miles, and gallons, to name a few. However, there was no uniformity in the conversion of one unit to another. In 1791, the French Academy of Science introduced the metric system. Under the metric system, the units of physical quantities relate to each other as multiples of power of 10. For example, 1 kilometer equals 10 to the power of 3 meters. This system was found to be convenient and hence was used worldwide. In 1960, the metric system was improved at the General Conference of Weights and Measures to create a new system called the International System of Units, or SI, which is short for System International in French. The SI unit pertains to 7 fundamental scientific quantities. They are length, measured as meter, mass measured as kilogram, time measured as second, electric current measured as ampere, thermodynamic temperature measured as Kelvin, amount of substance measured as mole, and luminous intensity measured as candela. Let's look at each quantity one by one. The SI base unit of length is meter. Meter is the length of the path travelled by light. In vacuum, during a time interval of 1 by 2997,92458 of a second. The SI base unit of mass is kilogram, which is equal to 2.2 pounds. As per the SI unit, kilogram is the mass of a specific cylinder of platinum-iridium alloy kept at the International Bureau of Weights and Measures in France. Thus, it can be defined as the mass of the international prototype of the kilogram. The SI base unit of time is second. It is based on the radiation from the cesium-133 atom and is defined as the duration of 9192631770 periods of the radiation, corresponding to the transition between two hyperfine levels of the ground state of the cesium-133 atom. The SI base unit of electric current is ampere. It is named after André-Marie Ampere, a physicist who discovered electromagnetism. It is defined as the constant current which will produce an attractive force of 2 × 10⁻⁻⁷ Newton per meter of length between two straight, parallel conductors of infinite length and negligible circular cross-section placed 1 meter apart in a vacuum. The SI base unit of thermodynamic temperature is Kelvin. It is the fraction of 1/273.16 of the thermodynamic temperature of triple point of water. The SI base unit to measure the amount of substance is mole. Mole